We're doing a lesson today on the Pythagorean Theorem. We got some vocabulary terms, so we're going to get right into that. The first vocabulary term says the side opposite the right angle in a right triangle. So if you look at this triangle down here, here's the right angle, this side opposite that. It's the longest side always in a right triangle, and it is called the hypotenuse. Kind of a funny name there for one of the sides of a right triangle, hypotenuse. The two sides of a right triangle that form a right angle. So in other words, in this one right here, this triangle, the sides A and B, these two that make up the right angle, those are called the legs. So you got the two legs and then the hypotenuse. All right, and then this one, it says in a right triangle, the square of the length of the hypotenuse, which is side C, is equal to the sum of the squares of the lengths of the legs, A and B. In other words, A squared and B squared equals C squared, as we have explored in class already. This is called the Pythagorean Theorem. So you got a little key concept box here. It talks a little bit about the Pythagorean Theorem. It says in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. That's our vocabulary definition up there. It gives you the symbols here, side A squared and B squared equals side C squared. And then you also have kind of a picture of the triangle there as well, where we're able to identify the legs and the hypotenuse. All right, let's get to the steps here. What can we do with this now that we know that the Pythagorean Theorem works? How is it useful? So to help us figure that out here, we're going to look at these steps here. We can write an equation using the Pythagorean Theorem, basically plugging in what we know already, and we can use that to find the length of missing sides in a triangle. So if we know two of the sides of a right triangle, we can find the third side. So it says write an equation you could use to find the length of the missing side, then find the missing length, round to the nearest tenth if necessary. So we got 5 steps today. But once you get the rhythm of this, once you get the hang of this, it actually goes pretty quick. And it's kind of a nice rhythm to solving these Pythagorean Theorem problems. So I think you might actually kind of enjoy these Pythagorean Theorem questions that we're working on today. So the first thing we need to do is make sure that our sides are labeled correctly. So sides A and B are always the two legs, and side C is always the hypotenuse, the longest side. It doesn't matter which one of the legs you label A and which one you label B, as long as through the rest of the problem you're consistent with which one is A and which one's B. So it doesn't really matter. I'm going to call this one over here A, this one here B. Side C is already labeled for us there. That's the longest side. Then we're going to plug those numbers into the Pythagorean Theorem. So let's do this right here. A we now know. So here we're using this Pythagorean Theorem as a model right here. We're going to plug in what we know for A, plug in what we know for B, and C we don't know. So we're just going to leave it C for now. We're going to leave it a variable. Okay, so 12 for A squared plus B, we know is 16 squared, equals side C squared. So yeah, again, because we don't know what C is, we just leave it C. So it's just plugging in what you know. Step number 3, square the numbers. So we're going to actually go ahead and square these now. 12 squared, you should know some of these squares because we worked on our perfect squares earlier this year. 12 squared is 144. I only had you memorize through 15 squared, so you might not know 16 squared. It's 256 equals C squared. Since we still don't know what C is, we can't square it, so we're just going to leave it C squared. We squared the numbers, so now we're going to solve the equation. In other words, we need to get C squared by itself. So right now it is by itself. We need to go ahead and add. These are two like terms on the same side. 144 and 256 need to be added together. So 144 and 256 gives us exactly 400. So 400 equals C squared. But that's what C squared equals. So this side length is not 400. That's what C squared equals. So if we squared this side, that'd be how many square feet would fit in there. So we don't know what C squared is. We want to know what just C equals, just the length of side C. We've talked about this earlier this year, so I want you to see if you can think of this before I tell you what the answer is. How will we undo a squared? What is the opposite of squaring something? So think about that and see if you can remember. The opposite of squaring something is to take the square root. Squared and square root undo each other. So if you take the square root of that side, you got to take the square root of this side as well, so that just c is left over. And the square root of 400, in other words, what number times itself equals 400, is 20. Now let's see if that makes sense. I like to kind of do a common sense check. If this is 20 feet, it has to be the longest side, but reasonable with these other numbers here. So this is 12, this is 16, 20 is the longest side, and it's reasonable there with 12 and 16. It's not a completely unreasonable number there. All right, let's go through some more of these. Let's do some more practice down here along the bottom. It's the same instructions we just had. Write an equation you could use to find the length of the missing side of each triangle. Then find the missing length. Round to the nearest tenth if necessary. So step number 1, make sure the sides are labeled correctly here. So I'm going to label this side, side A, this side, side B, side C is missing there. So I'm going to plug in, step number 2, plug in the numbers into the Pythagorean Theorem. So I know for A, I've got 15 squared. For B, I've got 20 squared. And C is unknown. Step number 3, square the numbers. 15 squared, that's one you guys are supposed to know, that's 225. Plus 20 squared is 400, so 400 equals, we still don't know what C is, so we just leave it C squared. Now, 225 and 400 are on the same side together, so we're going to solve this equation. Those should be added together to give us 625 equals C squared. But we know that this side is not 625. That would be the largest side, but that's unreasonable with these other numbers. If this is 15 and this is 20, then this should probably be something in the 20s, right? But not 625. So we have to undo the squared. We have what C squared equals, but undo the squared by taking the square root. That's going to be our last step every time today. Take the square root to undo the squared. The square root of 625, in other words, what number times itself equals 25? I know what it is, but I want you guys, we're going to be using calculators some today. So if you don't have a calculator, you need to pause the video and go get a calculator. And make sure that we remember how to take the square root of things on the calculator. So press second, and then the button to the left of the 7 there to get the square root sign, and then 625. So finish out that square root there, or finish off that parenthesis, and hit equals, and it's 25. So this side length is 25. Let's make sure that makes sense here. If we plug in 25 right there, this is 15, this is 20, that would be 25. That's reasonable. It also, C is still the longest side, so that seems to make sense. Let's do another one here. Step number 1, label the sides correctly. The two sides that make up the right triangle, or excuse me, the right angle are A and B. Doesn't matter which one you label A and which one you label B. So I'll call this one A, call this one B. The longest side, the hypotenuse across from the right angle, is always side C. So we're going to label that side C. Step number 2, plug those numbers into the Pythagorean Theorem. So let's go ahead and do that. We know it's A squared plus B squared equals C squared. You have the Pythagorean Theorem there. You can look back at it if you need to. Yeah, so let's go ahead and plug those in. So A is 9, so 9 squared, plus B this time is unknown. We have one of the legs that's the unknown side. So this time we just have to write B squared equals C is 15. So it's going to work out just a little bit differently with one of the lengths of the legs being the missing side. But we still go ahead and continue to solve. It's just going to, when it solves, it's going to look a little different here. So we've plugged the numbers in. Now we need to square the numbers. Step number 3, square these numbers. 9 squared is 81 plus B squared equals 15 squared. We've already done that today. That's 225. Okay, here's where things are a little different. We need to isolate B squared. So far we've just had C, and it's already been by itself, but B squared is not by itself. So this time, we need to get rid of the 81. We're going to subtract 81 from both sides. So B squared equals 225 minus 81. I think that's 144, isn't it? Go ahead and just, let's see, 5 is 4. I have to borrow from the 2 there. 12, 4, yeah, 144. So 144 for B squared there. But that's what B squared equals. Remember, our last step today is always going to be to take the square root of both sides. So B equals square root of 144 is 12. So 12, that's one of those perfect squares you should know. 12 is what B equals. So this one was 25. Let's go ahead and put meters here. Forgot to do that. On the side it says 12 feet. Okay, let's do a little more work with this. Let's flip this over to the other side and see what they want us to do. This is just continuing the instructions from the first side. So I'm going to give you two side lengths, and we're going to find the missing side, but this time we're not going to have a picture of a triangle. So for the first one, A equals 6 centimeters. You need to write this down. And B equals 5 centimeters. So this time we don't have to do step 1, which is to label the sides, because we don't have a picture, and we are already told what A and B equal. So step number 2, plug the numbers into the Pythagorean theorem. So we now know what A is, so instead of A squared, we're going to write 6 squared. We know what B is, it's 5, so 5 squared. And C is the unknown, because it's not listed here, so we have to write C squared for now. Step number 3, square the numbers. 6 times 6 is 36. 5 times 5 is 25, equals C squared. Now 36 and 25, if you add that together, that gives you 61. They're on the same side together, so 61 equals C squared. This is the first one we're going to run into today that does not give us a whole number when we take the square root. The square root of both sides, that'll cancel out. We're going to do just one number after the decimal. We're going to round to the nearest tenth today. That's what the instruction said to do. It said find the missing length, same instructions here. Find the missing length, round to the nearest tenth if necessary. So this is the first time we're going to have to do that. Let's break the calculators back out here and take the square root of 61. It is not a perfect square. Second, button to the left of the 7, 61. Finish off the parenthesis there. 7.8. 7.8. And that's going to be centimeters, it looks like. We know how to estimate square roots, and we may do some of that with these, but for the sake of speed and getting this lesson, getting as much instruction as I can in here, I'm going to be using the calculator for those square roots. But we could estimate those. We know how to do that. Number 4, we have A is 9 millimeters. And, oops, yeah, let's call this one C. I don't know if I originally planned for this one to be C or not, but let's call this one C, is 14 millimeters. Okay, so we have a side length for A, we have a side length for C, but this time it's B that's missing. So I'm going to plug in what I have for A, it's 9 squared, plus B is not listed here, so it's the unknown this time, equals 14 squared. Okay, let's go ahead and square those. 9 squared is 81. Plus B squared equals 14 squared is 196. But this time, B squared is over here on this side. We're going to subtract 81 from both sides. And B squared equals 196 minus 81. Let's see, it's 5, 1, 1. So it leaves you with 115. So now all we have left to do here is B squared equals 115. Let's take the square root of both sides. So B equals whatever the square root of 115 is. Second square root, 115. And 10.7 it looks like. 10.7 millimeters. All right, we're getting low on time, but I want to do at least one of these here before we close out the video today. It says determine whether each triangle with sides of given lengths is a right triangle. Well, the Pythagorean theorem only works for right triangles. So one of the things you can do is if you have all 3 side lengths of a triangle, you can test out whether or not it's a right triangle by trying the Pythagorean theorem on it and see if the 2 sides really do come out equal. If A squared plus B squared really does equal C squared. So we're not finding the length of the missing side this time. We're testing out whether or not the side lengths make a right triangle. So 5 feet, 8 feet, and 9 feet. So the first thing we're going to do is we're going to label the sides A, B, and C. We know that all the side, or the longest side is always going to be side C. So of these right here, this is going to be C because it's the longest side. But these 2 here, doesn't matter which one you label A and B. So let's just go ahead and go in order, A and B. So we have all the sides this time, but we're going to see if it really comes out to be equal on both sides. So A is 5, so 5 squared. B is 8, 8 squared. And C is 9, 9 squared. So we'll square all the numbers here. 5 squared is 25, 8 squared is 64, and 9 squared is 81. We're going to go ahead and add these together on the same side together here. 25 and 64. Let's see, that should be 89, right? So 89 equals 81. Well, does 89 equal 81? No, it does not. So we're going to say that no, we're determining whether or not this is a right triangle. No, it's not, because A squared plus B squared did not equal C squared. If the 2 sides did come out equal, then we would say yes, because the Pythagorean theorem would have worked. But remember, it only works for right triangles. So no, this is not a right triangle because a squared plus b squared did not equal c squared. We'll do some more work with the Pythagorean theorem in class. We'll see you guys then.